In a previous video I showed how to set up a rig which allows me to change the resolution of a shot camera whilst maintaining a uniform 100 pixel size on any checkerboard that I have connected to that via a Project 3D shader. Indeed, this is the scene which is where I left off at the end of that video. So what I want to do now is I want to build on this to complete the projection rig by setting up a control system that allows me to quickly and easily make changes to the resolution of any projection camera in the scene, even if I make changes to the focal length to gain extra coverage, which is known as overscanning. So what I'm going to do is I'm going to select these bunch of nodes here and copy those and paste them over here, and this is going to be the site of my first projection. I'm going to select this checkerboard and I'm going to get rid of the green tones and add in some red tones instead, just so we can distinguish between these various checkerboards. Just turn that down a bit more to make it a bit stronger. Okay, so we've got, just take a look at that, we've got a decent checkerboard there. We've also got that text box there, which I don't need anymore for this because this is not a shot camera, and that one on there is just basically to distinguish the shot camera. Okay, so this is our new texture that we're going to be using as the source of our first projection. You may remember that I created a projection camera, but I didn't lock it off at any frame. I just kept it so that it's basically exactly the same as the shot camera. And this is obviously a duplicate of it, but this time I do want to lock this one off. So for that I'm using a frame hold node, and I'm just leaving it set at the first frame, which means that now this camera is locked at the first frame. So this projection isn't going anywhere. It's just basically in the fixed first frame position. And now I need to connect this into this pipeline, and for this I need to merge my shaders, and the node I use for this is called a merge material or merge matte node. And what I'm going to do is I'm going to connect the A side to the shot camera and the B side to this projection. So essentially whenever I add to this, the shot camera is always on top, so the green texture is always visible on top. Okay, so if I zoom into this now, eventually it will come into view. We can see our scene here, and we should be able to see our shot camera moving across the scene, and we can see our projection camera, which has been locked off by the frame hold node, and we can see that that is in shot. I'm actually looking at this just in the OpenGL view rather than through the scanline renderer at the moment, hence the reason why I'm plugged straight into the geometry rather than into the scanline renderer. And you can see that on the first frame we see 100% of the shot camera, which is pretty much what we'd expect, and as we start to emerge through this and the texture from the shot camera starts to slide across to the right, basically reflecting the movement of the camera, we start to see the projection camera from frame 1 starting to peep out from behind, and we see that sort of increases until we get to the last frame where this has carried on behind, and we can see that through that process coverage at least on the lower part of the building is maintained sort of through the camera move, even though we do lose some coverage up here on the top. Okay, but the purpose of this is not really to solve this problem, it's actually to address the issue of maintaining sort of the rig and the integrity of the rig as we start to make changes to these projection cameras. Okay, so for this to work, I'm going to use this node, which is a gizmo that I created. I'm going to use it as a tool to control this projection camera. I call it the focal length finder. We can see that when it's open here, it's a dead node, apart from the fact that it carries a load of values which I can use to drive the projection camera. I'm going to start by setting the original width and the original height to the display format, which is 1920 by 1080, and I'm going to set the original focal length at 35. And that is pretty much all I need to do for now. that is now sort of going to give me something, but obviously I now start to need to connect it to different attributes within the projection camera. And as I said, it's going to be connected entirely by expressions, so there's no need to use any of the input or output pipes from this. I just need to basically locate it within this bunch, because it's essentially it's going to be connected up to various nodes in this particular area. Okay, so I'll make a start. So what I'm going to do is I'm just going to set the node properties to 2, so I can't have any more than 2 nodes active in the scene at any one time. I'm going to bring in my projection camera, and I'm going to bring in the focal length finder, so I've got these 2 attributes here. Okay. So the first thing that I'm going to do is I am going to set the width and height to match of the projection camera to match the focal length finder, and I'm going to do this via the focal length. So in the focal length finder, I'm going to come down to new focal length, and I am going to right click in there, choose copy, and choose copy links. And then in my projection camera, I just need to turn that off. In my projection camera, I'm going to come into focal length, right click, and choose paste absolute. So now that value is set inside there. So what will happen now is if I start to make adjustments to this, so let me no, I can leave it there. If I start to increase the height, the width of the camera, you can see that that is dynamically changing the focal length, and you can see that I'm opening up the focal length of that projection camera, and what you'll see eventually is it starts to open out and essentially fill the space. And remember that we work on the basis of double resolution, so you can see here that this is 1920, so I can go up with this up to 4000, and you can see that by this point here, 3800-ish, 3700-ish, you can see I've pretty much covered the entire area with that. I am actually going to come down a little bit just by integers, because I want this height to be a whole value rather than just a fractional value as it is, so I'm just going to come down until the new height turns into a whole value. Just a little bit fiddly, there we are, look. So at 3712 the new height is 2088. With projection cameras, because you're actually projecting the surface within the frame, it doesn't really matter that much, but I like to be working with all integers when I'm dealing with these values. So to make this a little bit more informative, I'm actually going to put some values straight into this label area. So I'm just going to click in here and fold that up. I'm actually going to put some values straight into here. So I'm going to start by putting in parentheses and adding in, or should I say angle brackets, and I'm going to type in value new FL, which is the new focal length, and I'll actually put that in as well as a label. So you can see there that it's telling us that the focal length, the current focal length, is 18.103, etc., etc., etc. Okay. So what that means, therefore, is that this is a dynamic text element. So if I start to increase or reduce the amount of focal length by changing the width, you can see that value dynamically updates. So right inside the node graph, I can see exactly what's going on. Okay, I'm going to do a similar kind of thing with the width and height as well. So I'll type resolution, and then I don't want a semicolon, and then I'm going to type value new width multiplied by, and then open up and close the brackets again, value new height. Okay, spaces either side of the X. Not that it's necessary, but probably more attractive visually. And also I'll attempt to spell resolution something like correctly, and we can see now that the focal length and the resolution are both being inputted directly into the text path for this particular node. So I can see right down here on the node graph exactly what's going on inside these values. So pretty useful, that. Okay, so I'll zoom back out with this. And if I want to, I can grab those layers there and add a backdrop, and you can see now that I get a backdrop which, in theory, is scaled to that node configuration, but usually it scales a little bit too tightly for my liking, so I tend to just open it up a touch. So, and I could go in there and name that particular projection and keep that backdrop there, and so all I have to do in future when I want to make new projections is just copy that entire backdrop with the nodes, and then just make the various changes, like recolor the checkerboard, etc., and then make the various changes inside here. Okay, so when we're setting up these projections, we have to perform two separate functions to the checkerboard. First of all, we need to double the resolution to reflect the standard protocol that matte artists use, which is to paint the matte painting at double the display output resolution. So in this case, the display output resolution is 1920 by 1080. So a matte artist would be typically building a matte painting at a resolution of 3700 and odd by 2100 and odd, which is double the 1920 by 1080. Typically I tend to round up to 4000 by 2250. That's just because I'm really anal and I like whole integers. Okay, the second function which we need to address now really is to make the checkerboard reflect the changes made to the focal length finder attributes, because obviously if we're going to be looking at projections like this within the viewport area and we start to make changes to resolution and to focal length, overscan, etc., we need to be making sure that when we do comparisons between the checkerboard patterns on different projections, that they're matching up and we don't end up with ridiculously big squares in one area and small squares in another. And of course, making sure that our checkerboard pattern conforms to 100 pixels so that they stay the same irrespective of the resolution is absolutely pivotal to that. So how we know that's not working is because in our focal length finder we know that we can see down here our focal length is 18.10, our resolution is 3712 by 2088. But if we look in our checkerboard, something weird going on down there, you can see the root format is the standard display ratio of 1920 by 1080, but scaled twice the size by this reformat node, and this is basically the same property as we used when we did the shot camera. It's obvious because we actually made a copy of this, and there's no reason to jettison this at this stage, but what we do have to bear in mind is that these values don't tally up. They're not being influenced in any way by these new values that are going into here, and we need to do that now. So to do this we have to add another reformat node. Oops. Okay, so we've got this second reformat node which actually sits directly below the checkerboard. And what I'm going to do inside here is different to the previous one where I set it to scale. I'm actually going to set this one to box, and then I'm going to enable the force this shape. And what this allows us to do is it allows us to change the resolution based on the width and the height, and that obviously ties in very well with this focal length finder, because we've now got a field for new width and new height that we can basically copy straight in. So I'm just going to take both of those nodes, and we know that we've got our new width here, and we're doing exactly the same thing as I did with the focal length. So I'm taking my new width here, right click, choose copy links, and I'm coming into the width height box, right clicking, choosing paste absolute. We can see that that value gets interpreted, and then the same with new height, coming in here, copy links, and then in the new height paste absolute. So now the values inside here are now being influenced by the resolution that's dictated to by any changes that I make inside this focal length finder. And essentially this is, I want to be basically controlling my entire projection from this single interface, and I don't want to be dipping in and out of any of these reformats or any attributes inside the checkerboard. I just want to be controlling the whole thing from inside here. That's the whole point of doing this rig. So I guess now if I come into my new width attribute and I start to make changes, you can see that those changes are automatically happening now inside the format, the width height format of my patch projection or my projection camera. You can see that visually in the screen, because you can see that I'm scaling up and down the resolution of that projection from there, and you can also see it in the values of the reformat attributes. You can see these values down here changing as well. So we've got a dynamic relationship now between the width height as dictated in the focal length finder and the width height that's dictated within the reformat box. So that has solved a problem and created another. And to assess that, I'm just going to bring the viewer up and we'll take a look at this in 2D. So you can see I've connected the viewer directly up to this reformat node, and I want to just check the width of my checks. So we can see that here that is 1860, and we can see over here that this is 1987. Okay, so we've lost the relationship between, we've lost the 100 pixel relationship that we created earlier on when we're working with the shot camera. Now that we've introduced some changes here, we've lost that relationship, so we need to reinstate that. And to do that, we're going to need to go back to this checkerboard, and we're going to need to go back and update this expression. So I'll right click on it and choose edit expression. I'll bring it into screen, and I'll just try and extend it a little bit to give us a little bit more space. So hoping I could bring that down a little bit more. Okay. So I'm going to need to change this expression quite a bit. Essentially what I want to do is I want to discard that bit in the middle. Make a little bit of space in there. And what I want to do instead is I want to take the values from the focal length finder. So I'm going to choose focal length finder 1, which is obviously the name of the node, and then I want to get the new width attribute from there, and then I want to divide that by the focal length finder original width, and then multiply by the 100. Okay. I'm getting an error there, and that's because I've spelled the the expression wrong, which I'm sure you will have seen while you're watching that I spelt width wrong. Why didn't you shout up? Spelt it wrong again. I'm all fingers and thumbs. Okay, so new width, a ridge width, that looks okay now. Still doesn't look right. So I'll come back in, edit the expression again. Let me see exactly what's wrong here. There's a rogue eye got into the ridge width. I think that should fix it. So third time, or is it? No, I'm going to need a fourth time to get this right. Spotted it. It's the dot that's missing there. Okay, so finally I get the expression correct. Okay, now we can see it's a little bit, the result that we're getting is a little bit funky. What's going on here with this E05, etc. Okay, that's essentially because this this equation isn't quite correct, giving us this strange value. And the reason for that is that I need to get the ratio that's computed inside here before the operator at the beginning and the end kick in. So to make that work, I just need to add parentheses. So I'm just putting an opening bracket at the beginning of that part of the equation and then a closing bracket at the end. And now we can see that what's happening now is it's getting the ratio from this equation, and then it's applying the operators that are on either side of the parentheses brackets. So we're getting this result. Okay. All right. So what this means now is that while we're on this, if we just hover over here, 1860, and come over to here, 1960-ish, then we're getting the 100 pixel ratio back inside our checkbox. Okay. So now let's connect to this next viewer, or this next reformat, and have a look at this one. So at that value, don't forget we're looking at the XY values down here. So we're seeing 2107, and now we're seeing 23 something. Let me go to my focal length finder. Okay. No, I don't need to do anything in there. But what I can see is at this point I'm getting a value which isn't 100, and that's because at this value the scale factor, that's the reason why it's funky, is because the scale factor wasn't 2. So what we should see now with the scale factor back at its original value of 2, which is creating a scenario where the map painting is double the display resolution, we can see there 2908, 3108. So we can see now that these are 200, and again that's completely understandable because we know that if we check it here and the pixels are 100, but then this scales the whole plot by 2, then the resolution is going to be doubled, but also the squares inside the checkerboard are also going to be doubled. So we need to fix that. So to fix this, we are going to have to go back into this expression. Okay, and again we need to compute this as an entire equation before it actually performs the operator. So what we need to be doing is we need to be dividing the value that's being gathered here, and we need to be dividing it by the scale value that's inside there. But again, we need to compute that entire value from the uppermost reformat first by putting the whole thing inside parentheses, and then we can do our division. So what we're dividing by now is reformat 2. Again, I've hit the wrong button. Reformat 2 dot scale, and that halves that value. So hopefully now, while we're at this point, we should have 100 pixel gaps between. So there, 2908, 3008, perfect. So all the way along now, we've reinstated our 100 pixel values as they're presented on the checkerboard, irrespective of what we do inside the focal length finder. We're always going to have 100 pixel values inside our checkerboard. And this is really important because we're going to need to compare the checkerboards from any projection with any other projection, and of course any projection with the checkerboard from the shot camera as well. Okay, so now this projection camera rig is set up, we can use this in conjunction with the shot camera rig, and we can start to add additional projections from here if we want to, and just start to stack them up. They would all start to stack up here using merge match. They would start to be added in. I would always want to keep the projection from the shot camera on the A side of this, so any new projection, just for example, if I just pull this down here for a moment and just copy and paste this, and say for example this is a third projection, so make this one blue, again we would have a merge matte, not a merge, merge matte, and again anything on this side would be coming in via the B side. That would be going into there, that would be going into there. Obviously I need to make a bit of space, and I'm really confined by the screen capture software. But now we've got a third projection. So say for example I wanted to set the frame hold at say frame 60 there, then this checkerboard is now projecting projecting something for us at frame 60, so we can see that starting to add into the mix. But our shot camera is always on top. So that is the premise behind this this rig. Once the rig is built, it can be used for any kind of projection configuration. So in this particular case, I'm going to be configuring a system for the geometry for the assignment, which is going to, or should I say, my own project, which is going to be more than just this one building. It's going to be an entire set of geometry that makes up this scene, and this is going to be the primary rig